Do you ever wonder how these massive companies, with thousands of people, manage to connect everything securely? It's not magic. There's this invisible set of rules running in the background, kind of like a secret digital handshake that makes it all work. And today, we're diving into exactly that, what we call digital trust. I mean, really think about it for a second. In a giant corporation, how does a computer in, say, the marketing department know it's okay to let someone from accounting print a document? Right? How does it trust them without just opening the floodgates to everyone? That's the puzzle we're going to piece together right now.
Well, the answer comes down to something called a trust relationship. It's basically a prearranged agreement, that digital handshake we were talking about, that sets up the rules for how different parts of a network are allowed to talk to each other.
Okay, so to make this super clear, let's use a simple story. Let's imagine two companies, Acme Inc. and Beta Corp. Each one has its own digital world, its own domain. Now, they need to work together, maybe share files or printers. To do that securely, their IT folks have to set up one of these formal trust relationships.
So in any of these relationships, you've always got two main players. First, you've got the user's home base. That's the domain they log into every single day. In our little story, that's going to be Acme Inc. We called that the trusted domain. Then you have the domain that actually has the resource, the one that has to decide, hey, should I let this person in? That's Beta Corp, and we call them the trusting domain.
All right, let's start with the most basic form of this digital handshake, a one-way trust. And, the name says it all. The trust here only flows in a single direction. It's a one-way street.
Yeah, the official term is a unidirectional authentication path. That's a mouthful, right? All it really means is that the trust, and therefore all the access, only goes in one direction. That's it.
So picture this. If there's a one-way trust setup so that Beta Corp trusts Acme Inc., it means Beta's network has basically been told, hey, anyone from Acme, they're cool. And just like that, an Acme employee can walk over, log in with their own password, and use a printer over at Beta. It just works.
But, and this is the whole point, it is a one-way street. The trust does not flow back. If a user from Beta Corp tries to turn around and access a server back at Acme Inc., nope, they're going to hit a digital brick wall. Access denied, because the handshake was only offered in one direction.
Okay, but what if you need a real partnership, where everybody can share and collaborate freely? Well, for that, you're going to need a two-way trust, which is more like a superhighway for access.
Now, this is a mutual agreement. It's simple. Domain A trusts domain B, and domain B trusts domain A right back. What that means is that those authentication requests, the system's way of asking, hey, are you who you say you are, can now travel freely between the two companies, in both directions. So, with a two-way trust setup, everything still works perfectly for Acme's employees. They can still get to all of Beta Corp's resources without any problem at all. And now, the superhighway opens up in the other direction. For the very first time, Beta Corp users can go the other way and access servers and files back at Acme Inc. It's a fully two-way relationship, and honestly, this is how most big corporate networks are set up by default.
Okay, so we get what these trusts are, but how does the system actually, check them? It's not just magic. When you try to access something, your request kicks off a very specific, very logical process.
This whole process is called computing the trust path. You can think of it like a digital roadmap that the security system follows. It literally hops from one established trust relationship to the next to see if your request is legitimate. So let's walk through it real quick. An Acme user asks for a file from Beta. Beta's server gets that request and immediately pulls out its map of trust relationships. It then tries to figure out if there's a valid path from itself all the way back to Acme's domain. If that path exists, the light turns green. Welcome, access granted. But if there's no path, the door slams shut. Access denied. It's that simple.
Now, I know what you might be thinking. This sounds kind of old school, right? Especially with all the talk about cloud computing these days. But the truth is, these principles are the absolute foundation, the bedrock, of how large-scale enterprise security is built, even today.
And this is why it's so important. This whole system is what allows different departments or even different companies to work together securely. It's how IT can manage a gigantic, sprawling network from one central place. It's even the magic behind single sign-on, where you log in just once to get access to everything you need. It creates order out of what would otherwise be total digital chaos. And really, if you want to boil it all down, it comes back to this one idea from the source material.
Before you can get in, the system has to check the guest list. It has to make sure that a formal, pre-approved trust relationship actually exists. It's simple. No trust, no entry.
And all this brings us to a really fascinating question for the future. In a world of cloud apps and this new security model called Zero Trust, where the new rule is basically trust no one, verify everything all the time, is this old idea of a defined digital border starting to become obsolete? Is a digital handshake becoming a relic of a simpler time? Something to think about.